Go.
Hello everyone, my name is CHOU. Today I'm going to explain probability homework, week 11, question 2. So we have given a following function of v. So we want to check that it may present an autocorrelation function of a WSS stochastic process by setting v equals to tau, or a spectral density function by getting v equals omega, or both. So we want to find out which function f v may represent either or both and explain our answer. So for the first function is f of v is equals to exponential power of negative absolute value of v. So if r of tau is an autocorrelation function of a real WSS stochastic process xt, then it is even, and r tau is less than equal than r0, and its Fourier transform is non-negative. And also if s of omega is a power sense spectrum of WSS process x of t, then it is not negative. So we have to check all these conditions. So for the first function, we can know that e exponential of power of negative absolute value of v is even, and also it is smaller than tau equals to 0, and the Fourier transform of this is 2 alpha divided by alpha plus omega square, and this is non-negative, so which this function can be represent an autocorrelation function. And for the second part, that our exponential power of negative absolute value of omega, which is non-negative, so this function can also represent a power spectrum. For b, our function is sine square v divided by v square. So we can know that the sine square tau divided by tau square is even, and the Fourier transform and which this is smaller than autocorrelation of 0, and also the Fourier transform of the function is non-negative, so which it can be represented autocorrelation. And for the second part is that is it a spectral density, so we can know that sine square omega divided by omega square, which this will always larger than 0, is non-negative, so it can also represent a power spectrum. So for the last function, f of v is equals to 1 and 0 when absolute value of v is smaller than alpha and larger than alpha. For the first part, it cannot be represented an autocorrelation function because its Fourier transform is 2 sine alpha omega divided by omega, which is not non-negative. And how about the power spectrum? It can represent a power spectrum because that f omega is always larger than 0, which is non-negative. And that's all. Thank you.